Hi, can you hear me?
Yeah, I can hear you now. Thank you.
Alright. How are you doing?
Yeah. Okay. All good. So is this your first time here?
Yeah, it's my first time here.
Okay. Where are you based?
Sorry?
Where are you located?
Oh, I'm in the UAE.
Oh, I see. Okay.
Yeah. What's about you guys?
Well, I'm in Hamburg, and I think Krishna is in France.
Yeah.
Okay, so I guess we can start. It's already 6 p.m. If anybody wants to join, they can join. So, just since you're new here, So since you're new here, just a little introduction. This is just like a weekly session we do on Python programming. There is no real agenda. So it's like whoever wants to come and share anything that they're doing in Python, needs help or wants to learn Python, can just join in. So as a reference, we usually pick some challenge from Kaggle or some other website which has data science or something else. So currently we are working through a challenge we found on Kaggle for trying to predict the sales of, I think, is it a Walmart? Yeah, it is a Walmart. For some Walmart stores in the US.
Sorry, how do you spell that?
Spell what? The site? Kaggle.
Yeah.
Let me just write it out for you. So it's Kaggle.
Thank you.
So the specific competition that we are, the data that we are using is in the link given here.
Oh, thank you so much.
Yeah. And typically what we do is we put the Jupyter notebook on GitHub, and that link I can probably share. So anyway, Shiva, when he shares his, I will just share that GitHub location as well, because so that if you want, like, this is already uploaded until the last session. What we did is already uploaded, and you can have a look at that and download that Jupyter notebook, and you can use that. So at the end of the session, whatever we have done, the specific Jupyter notebook will be updated, which is there. So right now what you have is what you have until the last week, and at the end of this session, I'll just clean it up and then put it up there.
Alright, I'll take a look.
I'm sorry?
I said I'll take a look.
Yeah, good. Maybe just a sec, before we start, Shiva usually asks, so what is your level or understanding of Python?
So I started using Python a few months ago.
Okay.
So I know how to, like, the syntax of it, but I'm not a very advanced user of it.
Yeah, me neither. So yeah, that's okay. It's just to know, so that we'll quickly go through what we are doing. If you don't have anything else to ask, or questions or anything that you can ask Shiva, or we probably will have to we'll start continue with what we were doing last week.
Sure, go ahead.
Also, what is your background? Are you like a student? Or what is it right now?
Yeah, so I just graduated engineering.
Okay.
So, yeah.
Oh, so which branch of engineering, by the way?
Mechanical.
I see. Okay, very good.
Okay. Yeah. If Harish joins, there will be 2 mechanical and 2 electrical.
Yeah. That's nice.
Yeah. There's another guy who regularly joins, and probably he's now in a transition to come to Europe. So anyway, okay. So Shiva, we'll then continue with what we were doing.
Yeah, I guess we'll just keep going.
Yeah. I'll share my screen, and I'll probably give a brief about, very short brief about what we have been doing, so that we will get going with it. So just a second. Oops. Okay. So, Shiva, do you see the screen?
Yeah.
Oh, is it? They have changed the interface because now I don't see the screen being shared on my own video. But if you see it, good. That's fine.
Interesting. Okay. Wow.
So, I mean, like, usually what happens is you see the screen on the video location.
Okay.
And maybe it's just a different setup. Maybe I don't know. Anyway, we'll probably have to check that. Anyway, it's okay. If you can see it, that's good enough. So, what we have here is a competition which expects, given about 5.5 years of data over 10 different stores across 3 different states in the US. They ask us to predict about 4 weeks of the sales data. So this is the fundamental idea. So they have about 3,000 different items, about 3,049 items, and in 3 different categories: household, food, and hobbies, and spread. So what has been given is the calendar, which contains the details of the dates and associated events, like whether there is a vacation time, etc. Then you have the sales data, that is how much of each of these 30,049 items were sold, and then the selling prices. So for a given week, what was the price of a given item? So these 3 data were given. What we have done so far is to put these 3, all these together in a way that we can use. So I will let these parts, the analysis parts, you can do it later, because I have added some comments, so there will be some comments for you to go through, and you can actually look back at the videos. Shiva, you probably can share your YouTube channel link, so they can look at the videos, past videos. But this current notebook has a proper tracking since last 2-3 weeks, but we have been doing it for a while now. But anyway, so what we did was to use Python and Pandas to do some analysis of how these data is, and for one specific shop. So we focused on a specific shop we called California 1, and for that we put the data together. So what did we do? So that I will let. You can have a look at it if you want at a later point of time. So what we did last week was that this is where we wanted to bring everything together. So what do I mean by that is we have the sell prices, which is, you can see that there is a week number which has a specific format. That is, the first 2 is a year, and I think this some format. So, and then they give an item, and for that item, how much was the selling price? Similarly, what we had done was we had put the date calendar also together with the selling prices. So we have the date, whether there is an event or not. So what we did was whether there is an event, which means the event would signify that there was a Christmas and things like that. So, but we just say it's 0 or 1. 1 means there is an event, 0 means there is no event. So with this kind of classification, what we have done is we have come to a point, okay, where we have, where do we stop? I think
we had stopped where we had actually mapped out the 2 data frames, but we were trying to make a check whether is it possible that we do not have a selling price, but we end up selling items, because then it's a bug. By the way, Harish has joined. Hi, Harish.
Sorry.
No, go ahead. It's just Harish is joining. Just wondering if he's in Europe or is he in India?
So he's probably still syncing up, I guess.
Oh, yeah. Can you hear us? Hi, can you hear us?
Yes, I can.
No, it's somebody else.
Oh, sorry.
Okay.
Okay.
Okay, he's probably.
Yeah,
Anyway.
there's some connection problem, I guess. Yeah.
I guess yeah, so basically the idea what we had decided, what we were doing is that we have selling prices and we have the number of items sold as two different data, right? So what we had done was we kind of tried to create two data frames which were kind of compatible. So they were the same items. One has the selling price for each day in those 3 years. The other data frame has the number of those items sold for each day in those 3 years. So now the check what is important is that we can have a case where there was an item which was on sale, so there was a selling price, but nothing was sold. The other case is there was a selling price, which means the item was on sale, and something was sold. And that's perfectly okay, these two. What we were worried of is that we could have messed it up in such a way that there might be some cases where there is no selling price, which means the item was not on sale. But if we end up with items being sold, then that is a bug. We need to go and investigate that.
Yeah.
So that's where we had sort of left off the previous video.
Yeah. So what we have hence is there is this sales data which has these are D1 to D1941 or the number of days for which we have data. And items are these 3049 items. So this specified how many items was sold on this day. And then we have selling data which has for the same set of items for these same days we have what was the number of these items sold. So these were the two we got, and we also created a revenue which was just a multiplication of each entry-wise multiplication. So we have the revenue as well. So what we wanted to be sure was we wanted to do a sanity check, and as Shiva explained, we wanted to verify it, and we wanted to see how to do it. So this is where we are, and let's.
So basically, just a question: is Harish able to hear us now?
Yeah.
Great. Where are you?
I'm in Norway.
Oh, wonderful. Nice to see you. Great. Welcome to Europe. Okay, very nice. Hope you had a good trip. So yeah, very nice to see you. Okay. Anyway, so we can continue. So what I was thinking, so basically what we're looking for is, let's look at the selling price data frame. So the selling price data frame, I mean, you can just write it here again if you want.
Yeah. I'm sorry?
Whichever, like you can just write it again just to be, or you can show it. Yeah, okay.
Yeah, I see what you mean. Yeah.
That's okay. It's okay. Oh, it's not run, I think. Oh, is it run? Yeah.
No, it is run, yeah. Yeah, it's taking time, yeah, I guess.
Okay.
Yeah, okay. And I'll say add.
So, these are the selling prices for each day, right? So now if you look, for example, if you look at foods 1004, which is on the 4th row, you will see that it is 0 for several days, which means that this item was not offered, which is not on sale. Now, if you plot the other data frame, that is the revenue data frame, not actually, the number of sales, not revenue. So here if you see, also for foods 1004, the 4th row, you see a whole list of zeros, which means that the item was not on sale and there was nothing sold. So obviously, because if it's not on sale, it can't be sold. So that's okay. What would be a problem is if any one of these items was, let's say, 2 or 3, because that means even though it was not offered on sale, you still managed to sell some of it, which means Either there's something wrong in the data or we messed up, right? So what we have to look for is, we are looking especially for this case. In the selling price, when that is equal to 0, right? We want to check if there is any other data where the sales is not equal to 0, right? So it's like this. So I'm just looking at, if all of you know about the logic patterns, it's like this. So if we do like an AND, right? An AND logical operator will be true if both arguments to it are true, right? It will be false in all other cases. Yeah. So if we say first argument is the selling price equal to 0, right? And the second argument we say, is the sales not equal to 0?
Okay.
So if the first one is true and the second one is true, then you will end up with some rows which are true.
Okay.
So maybe we can do that. So let's say,
so sales is equal to 0.
Is not equal to, because we want to make sure that this is not equal to. So this is not.
Is this the correct symbol?
I think it's an exclamation.
Sorry?
Exclamation.
Is this correct?
No, it's an exclamation mark.
Okay. I keep messing up. Okay. And you okay, this one is, you can do an...
no, you can't do.
Logical law?
Yeah, that's it. Because especially when you're doing queries,
And then you have pivot is equal to 0.
Is equal to 0. So now the whole thing can be casted on.
Let's say can we do a sum of this?
Actually, no need to do sum. Okay, what if you just run, not sum, just run it and see what happens? I think they might.
Okay.
Okay. Very good.
Okay, I'm sorry.
So now the question is, if we cast anyone.
If there is anything is true.
Yeah, exactly. So can you cast? Okay, you can do that also. No, this is fine. What you're doing is fine.
No, it's not doing it.
No, that is the problem. The problem is when you run it like this, it will give you the entire data frame. When you put this to a data frame. So you say sales dfca1 and then put this.
Okay. Test.
Oh no, it won't. You have to actually pass this to the data frame. So you get my point, right?
Sure. What do you mean?
So basically, when you do a logical operation like this, it will give you a data frame of true and false. If you pass that data frame back to one of them, it will give you those rows for which it is true.
I see what you mean. Yes.
Yeah. Okay.
So you want to say this.
Exactly. Right? And just put it in square brackets.
Yeah. Okay. So indices in pandas is square brackets.
Yeah.
Okay. There is a man everywhere, but
why should it be?
No, this is not right. Okay. No, this is maybe. Wait, just a second. Maybe do we have to do a list of something?
Okay. Can you test it out just on sales? I think what has happened is.
Or NP array.
No, just take sales dfca1 and only cast sales dfca1 is equal to 0. So just paste the first argument only and pass that to sales. It might be something to do with the...
Test it. You want to test it, right?
Yeah, exactly. Actually, you don't have to delete it.
Let me just do it. Because it's a lot easier this way.
Yeah. See, why are they non and not a non, not a number? Okay, put 0.0. Is there something with respect to the 0?
Maybe.
0.0. No. Can you just scroll up a little? Tell me what that is. 3.0. Why is it nan? Interesting.
So this is 4 is going to nan, and so wait, this one is going to nan. I don't know.
No, 3.0.
Okay,
See.
I think it is mostly to do with this.
Yeah, I think it is to do with the way it is resolving this to 0.
Yeah.
Now, how do we do that? Can you put like 1.0 e raised to minus 4 or something?
I'm sorry? What point?
Yeah, like e raised to minus 4. Because if it is like a resolution problem, that is...
e raised to minus 4?
Yeah.
See what
yeah. And make it 1.0. So like, it's actually like I'm putting a fraction. So maybe it is not taking it as 0, but it is taking some ridiculously small number. And put it as less than 1.0. Man, what is going on?
So it's putting it as NaN for sales data, right? Sales head is this. So whenever it is 0, it's fine. Whenever it is not 0, it is becoming NaN. Which is, it makes sense in a way, but in a sense, what is happening is if this is satisfied, it is putting a 0. This is not satisfied, it's putting an NaN. Okay, it's nothing to do with this, hopefully not. Yeah, that's what is happening. So,
I'm really surprised. Because typically it would just... Okay, for example, let's do another one. Maybe this is confusing. Make it between 2 and 3. 2 and 5. So, because I'm just trying to figure out what is this. It's kind of weird. So, greater than 2, less than 5. We need to sort of put them in parentheses. And no, it's 5. Don't put 5.0. I think that's missing. Just put 5. And it should be greater than 2. Yeah.
Okay.
Let's see what's going on.
Yeah, it's going to the same thing. So whenever the criteria is satisfied, it is giving that number. If it is not satisfied, it's making it NA.
Okay, so how do we use this? So let's go, if we go back to our own original, the one below, let's look at our thing, the query that we wrote below for our own case. So this is what we were trying to do, is equal to 0, and then if we cast it on sales, we are getting all not numbers.
Yeah, which means, so we will just have to check if everyone is not a number, right?
Yeah, so now what I'm thinking
That's all matters for us.
Yeah,
so
which means
if I cast this on sales, and then I say fill NA, for example. No, I mean, so okay, we get this. We get NaN everywhere.
No, I want to check. What we have to check, what we have to check? We have to check, can you now on this do another query that is equal to NP is NaN? Is not is equal to, again we'll get non. No, we can't. We are running into some kind of a loop.
What is this?
No, that's the thing.
So we have got now false everywhere. So what I mean is, let's say this, and then I say np.array of this. And I take the mean, for instance.
Okay.
So it says 0, which means, or I will say max, which is, okay, I think you can't...
I don't think, because it's...
So, I can do a sum of this right now. So, and then the double sum in fact. So it says 0, which means all of this are false.
Okay. Then I think it is satisfactory.
Yeah, so I will just write a comment here.
There has to be a more elegant way of checking if there is any element in a data frame which is not a number.
Yeah, that makes. I mean, I don't know. Yeah. So, but what we have done here is that we have tested something, but this is the only thing I feel it's a bit odd. The casting it back. Otherwise, I think it is fine. Let's. I mean, I don't know. Just a second. If I don't cast it, what were we getting?
Oh, you just get a whole lot of true and false.
Yeah. So this is enough. We don't need to cast it. In fact, right?
No, but the problem is, what happens is, usually when you cast it, right, it will give back those rows for which it is true. Typically, usually, when you do when you run a query. Oh, no. Is it to do with the index? Is it because the index has been cast to something else? Because I don't know if you remember, if you look at even some of the earlier videos in that thing, I was doing querying. And if you query something and you cast it back to the data frame, you will get only those rows for which it is true.
Yes. So, I mean, we can even try that for this, for instance.
But what I can't understand, even other things even other things that we did, like for example, checking if it is greater than 2, less than 5, that ended up with some really weird result. I think, you know why? Because if we end up with even a few false, right, that means, okay. You know what the problem is? The problem is that we are casting it in general for the entire data frame.
Yeah.
So what it is happening is, if we do it for a particular column, then it will narrow it down. So you can try
exactly.
that.
So it will do I think it will be able to pick a data series and not a data frame.
Mm-hmm. Yeah, I think so. That's probably what happens. So then if you want to crunch a data frame like this into a data series and then pass it, supposing we have a whole lot of false, right? Now, how will we collapse all the... Okay, can you do a little Google search?
Yeah.
Just check. No, what I want to do is performing a query across columns of data frame.
Selecting across multiple columns.
Apply a function to... Okay, can you check the next one? Pandas. Apply a function to each row column.
No, but that is apply.
Okay.
That we know. Okay, wait just a second.
Actually, you know what? A simpler thing will be this. Pandas checking if there is a true in a data frame.
What?
Checking if there is a single true in a data frame.
Okay.
Because somebody might have tried something like this actually. Okay.
Okay, there is something called iter tuples.
So what we want to do is just collapse this whole thing into one single true or false.
Yeah. What is this?
I think we can let it go maybe.
Yeah, I mean, this is doable, but this is like, going all over the place, right? You are checking, like what they are doing is check each row. Yeah, this is doable. Okay.
Yeah, I mean, it's seems like a brute force method. I just was wondering if there's...
There should be more elegant method. Maybe let's just try and do something.
Yeah, let it be now for now. Okay, I think we have otherwise sort of. At least we're satisfied. It's okay.
Fine. I mean, I will just this comment I will just add, and I think this is fine.
Yeah.
Okay, then we'll continue then.
Okay, good. So now we also have a revenue data frame, right? I think we calculated last time.
Yeah. So I will just revenue. Yeah.
Yeah. So this is the total amount of money made for each item for each day.
Yeah.
So now if we want to do, okay, now that we have all this data, we need to now go back and check our challenge question. What is it that we are trying to do? So that then we can use this data to sort of go towards the challenge.
Yeah. So the challenge question probably is given the 28 days after this 1941, the calendar information and the selling prices for those 4 weeks. Find out how many these items will be sold.
Okay.
Or the revenue generated over that period. Either of them are applicable. So technically, how much of the revenue will you generate? I'll just check what is that.
The objective is to advance it.
Now this is my summary, so it should not be taken as what they asked for, because this is something I wrote. I will just go to the Kaggle website and we'll see it. That there they probably will have better detail. Okay. Evaluation. Okay, I think this overview is better. How much camping gear will one store sell each month in a year? So something like this is what they are trying to do. So idea is you will use hierarchical sales data from Walmart to forecast daily sales for the next 28 days.
Okay. So we need
this data.
Yeah.
We will have to search for do the analysis and predict what will happen for the 28 days.
Okay. So now they have not asked for anything specific. So what they're looking for is the total revenue.
Yeah.
Right. So which means for each day we have to sum up all the sales of all the items. Right. And now what will be our challenge? So let's say, for example, if we were to predict what will be the amount of revenue for each store for 28 days, or let's say just for this one California store, right? Now, what we have so far.
I don't know whether they ask. I will have to check whether they ask for revenue or sales data, but let's assume revenue.
So, which means that the forecast daily sales, because otherwise it becomes pretty tough. It is very difficult to predict exactly each and every item, how much it sold.
No, I think for that we may have to do kind of a different thing compared to what we did. That is, you take an item and then look over 10 different Walmart stores for which we have the data for that item. Over that 5-year period where they have the data, put them together and then forecast how the item sells. Because that way we are able to look at item by item analysis. We say, okay, it doesn't matter, this item would be having the same effect whether it is California, Wisconsin, or Texas. So, I mean, that we may have to do some sort of some form of a assumption, saying, for instance, some items would not differ much. Some items will. For instance, Wisconsin is cold, which means it can be cold. So you're not going to see the same kind of camping gear that you sell in California be sold also in Wisconsin.
I think what we have to do. So let's
we can say food. We can say food category can be of that type where everything will be the same. Hobbies category will be different. Household perhaps different, slightly different, because depending on some internal household items will not sell the same, but things that are slightly different might sell differently. So maybe we can say food will remain the same. So if we want to do that, we can do it that way. But I think right now what we have is a single shop, and let's see what we can do with this.
Yeah.
For instance, take the take a few things, like let's say we can even categorize.
Yeah, now we have to categorize. So like, for example, if you go back to the data frame, so it's like this. We have to, let's say we take the simplest thing, that is we do, let's say, a linear regression. Okay?
Yeah.
So if you want to do a linear regression, then we need for 28 days an output, one output, which should be the revenue for that day. Right? So what that means is that this output, that is y, has to be a function of some x. Right? Now, technically this x is all the items sold in the store, right? Which is probably 3,000 something. So that's impossible. Or let's say it might be impossible. You could think of some kind of function thing, but for now we could say that in an initial case, it doesn't make sense to have 3,500 x variables and one output, right? So instead of
wait. So if we are doing linear regression, whichever regression it is, the inputs to the model will be the details such as the calendar, the day of the week, etc. Right? And so we will use, for instance, so we can probably develop a model for each item or a model for a category. For instance, let's say food category. We will create a model for food, household, and hobbies. So let's say we'll do 3 models for the given shop. So for that category, for food model for the food, we will have inputs such as what is the day, whether there is an event that happened, whether there was a snap, what day of the week is it, etc. And also the selling prices, because the selling prices we can probably do, for instance, take an average of the selling prices and see whether the selling prices being more creates a reduction in the overall thing or not. So technically we can use selling prices as also an input. And then look at the revenue generated for the foods item for that particular shop. So we can probably start with that.
Yeah, exactly. So we'll have to do some kind of a mean, or first what we can do is we can check out in our item ID. For example, if you see, it's like this, foods 1001. So if we take that item ID, that is our index, and we split it with respect to underscore, and we take the very first one, right? So then we will get kind of a category depending on these items. So we can try that. First we can just take this data frame, just take the index.
What is it?
No, so like revenue, yeah, CA1 and this dot index. Right. So this is our index, right? Now for this index, if you look, right, we are looking at the first string which is there before the first underscore seems like a kind of a category.
Yeah, it is.
So now what I would say is, so let's say for example, we create a little array of, like for example, an array of categories. We loop through this, we run the split on each one, right? We check if the first string exists in the array. If it doesn't, we add it. If it does, we let it be. So with that, we will get the unique categories which are there in this index.
Yeah.
Okay.
I think we already have it. There's 3 of them. Foods, household, and hobbies. I think we did that. But anyway, we'll do it again. So.
Oh, we've done. That's okay.
But not exactly this. We did, like, for instance, what we did was we had another column called category ID.
Okay.
So which just had these 3, and what I did was we did a categorical of that column, and then we just had 3 different items. So we had foods, household, and hobbies. So, but as you said, we can try it because this will be a quick, nice thing we can do. So we have this. So you want to
yeah, you can just create a new array first, like somewhere, like category of cats or whatever.
What?
You can just create a new fresh array, empty array called cats. No, this can be separate, not in this, because we have to write the entire function. Yeah. Now after this, we have to create like a for loop. So it's basically for item in index, colon, and this do that. So basically you have to just say if item dot split, and in parenthesis underscore
on, right?
No, underscore, just underscore. This is just, you have to just give this thing, string, yeah, and then pick out the first, so it's 0th element.
Yeah.
In cat items, or not in cat items, not in, so it should be not in.
You can do this?
Yeah.
Is it right?
Yeah, it should be right. And then if it is, then colon, just say cat items dot push, that one.
Dot append?
I think that's wrong spelling. Cat items.
Oh, yes. No, but is it append, right?
Yeah, it is append. And put just the split, so don't put the whole thing.
Yes. Okay,
try it out. Okay, try it out.
See, what is it? Yes, food, hobbies, and household.
That's actually pretty narrow.
Yeah. So, in fact, there is also a different thing. Like you see that there is an item ID which is a category foods underscore 1 food underscore. So there is a slightly bigger category, but the problem is I do not know how many of this are. How many of it? How do we say? How many of it is? Are they really grouped together or not? Like we can quickly check. For instance, in this, we do this, right? We can we do this 0 to 2, right? If we do this, it'll just do a. I think there are some. So yeah, you see that. I wanted to do this foods underscore 1 underscore 2 underscore 3. So you see that there are 3 categories of food, two categories of hobbies and two categories of households. So it's not really a big difference. So if you want, we can actually do a model like this. So
okay.
we have three.
So then what we have to take is, we have to take, it's like this. We don't take, how will it be? Split 0. Okay, so first actually we have to go and set it to null again and then repeat it. So cat items is equal to null and then repeat it. Yeah.
Yeah, sorry. Yeah, that's true.
Okay. So what we can do instead is, instead of appending that 0 colon 2, we can just add those 0 and 1.
Yeah.
So separately and then separate the whole thing with 1. That will be 1. No, that will be 1. It can be 2.
Oh, no.
Oh, you have to put an underscore again.
Oops, sorry. No, it is. It's not able to. I think. Okay, wait. Because when it does this, again we okay. Let's do this because I think we have to do the same thing here. Yeah. So I'm going to say item cat is equal to this, and then I will check if this is existing.
Oh, okay.
Because this is why it is not able to, because it's testing different things.
Yeah, it's testing. Okay.
Yeah, now you say.
Okay, good. So now what we have to do, is there an underscore the last one?
Sorry?
Is there an underscore in the last one? I'm not able to see it. Household 2. Yes, household 2. Yes, okay.
Sorry.
So now what I would say is, we can now create another column in this data frame, in the data frame above, like all revenue or sales, selling or whatever we want to do. We can create another column and add this and apply it, saying that we are checking if the index has one of these, then we add that value.
Okay.
So
okay. Yeah.
Because the idea is we want to group by.
Yeah, one thing we can do, Shiva, maybe, is let us now create a new revenue cat 1, where the items, we will put them all together into these categories. Let us not anymore have such a big data frame. Because if we add one more...
No, I think we need to, because see, it's like this. If you want to do a prediction thing, right, we will need for each day the mean value of each category.
Yeah.
So then with that mean day, we can then do additional things. Like for example, we can group it with respect to, every 30 days or every 5 days, or we can look for the, like the day of the week or all those things.
Yeah. No, my question was this. So perhaps I was not clear. So my question was, look, we have these categories like this. Instead, we will now replace this. So I think there are 3049 items groups here. Rows. Let us have only 7 rows. That is what I'm saying.
It will become. Because once you do a group by and a mean, right, it will automatically become.
Okay. I mean, I was just saying that, okay. Yeah, fine. Let's see.
Yeah.
Because for that, I think we probably could have. Anyway, we are going back and forth partly because this existed in the columns, but we are now going back. But anyway, it's fine. It's just that we removed them, but now we think we probably need it. But anyway, that happens.
Yeah. So basically, we just have to do a little apply function. So we just have to take the index, that is this revenue. We can just take revenue, whatever. Say revenue CA1,
Mm-hmm. So we'll just have to check the index, and if it corresponds to this, first two element corresponds to this, we will put this as the column.
Yeah, what we'll do is like this. We have to, what we'll do, if you just do, like, for example, supposing you do, it's like we loop through the index, okay? Then we check if, like you said, the first two of that index, if it exists in one of them, or can we do it a simpler way without doing a split again? Can we do it the other way? That is, we loop through, because this index is very small. Let's say this cat items. So if we loop through cat items and we say if one of these exists in the index, then we return that as the value of the series at that part. Okay, let's just do it and then we'll see. So for example, if you just start with index, let's say for example. So revenue, and then you say dot apply on that. No.
You want to apply here?
Yeah.
Okay.
So what I would say is, now, okay, we can't do a lambda, it'll be too complicated. So write a function above that. Any function. You can just say item label or whatever.
Mm-hmm.
And then x, give it x. So what we're going to look for now, if we say for cat and cats items,
what?
For like that, we are now looping through the categories.
Okay. For.
And then we just have to say if cats in x, then return cats.
But wait, so will I be able to look at it through this kind of specific grouping? Like the string check it does?
Yeah, this string check it does.
Oh, okay, that's good. I didn't know the substring check also it does.
Mm-hmm.
If cats in x, okay,
then
then
return cats.
I'm sorry?
Return cats.
Yeah.
Okay, and just pass that function. You have to execute the function. You have to, I don't think it will come with that.
Apply item labeling, right?
Yeah.
Okay.
Mm-hmm.
This is a...
because it is like, okay, so what is happening is it's taking, okay, can you put index again in bracket but with a string, because it is sometimes, it is a reserved this thing, yeah. So just say index. No, just try it. Index, try writing.
Should I have to put
No, write index, start writing index.
I
index, 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 try it out.
No, nothing is there.
I see.
No, actually, the problem is, I think, is if you do this, the type of this is what?
I think it's, oh, okay, I think maybe it's an array.
See, it's a pandas core index base, so we'll just have to convert it into something else.
Oh, okay.
Let's say,
just say pd.series.
No. Temporary data frame.
No, just say pd.series and just see what happens to that.
Okay.
Okay, go ahead.
Yeah.
Okay. So then you can just do apply on that. Okay, done. So what we have to now do is we have to say that revenue save one, you can give it a new column called this thing. I don't know what, category, whatever, yeah, is equal to that. And this can be applied to, I think, each and every one of them. So you can just change the name, and so you can just try it and just see. Because we have 3 data frames, if you want, we can do it for all 3.
You mean sales and selling prices?
It will be at the end, that's the problem.
Yeah.
Yeah, that's, oh,
it says NA. That's strange. There is something strange because it's saying NA.
yeah, why?
When I just do this, it's fine.
Why?
But
It is a series.
Okay, let's say temp x this, and then so when I do this, underscore series, and then
you know why? Because the index is different. So what we have to do, we have to say dot series. We have to then say the index is equal to the index of this. So for example, see this temp x, right? You have to cast the index. So what we have to say for temp x is for temp x, delete temp x, delete that this 154. No, 154 line. So what we have to say is temp x dot index is equal to revenue CA1 dot index. Or let's try this, otherwise we'll have to do a set index. And now try to see what is temp x. Yeah. So now you see. So now try to do that thing again, column.
Okay.
Because the indexes are different, so it just couldn't find it.
Okay. So we just add a comment. And now we'll say this. So we'll have to remove this, right? This is not.
Yeah,
right.
that's not necessary. Yeah.
Oops.
No, the other way around.
Oh, yeah. Sorry. Okay. Now we should get. Full one.
Okay, good. So now coming to I think we're almost out of time. So we can just do a quick group by, and we'll just do of this. So if you do revenue CA1 and you do a group by.
Just a second.
Yeah. And then just do shift tab. Let's see what it has. I forget all the time. By is equal to, so what we'll say, by is equal to that category. By is equal to category, and then we have to, where is that thing? Come down a little. Okay, I think we have to put the sum at the end of it. That's okay.
Yeah. So we'll do
by is equal to category as string.
No. Okay.
And then dot sum at the end.
Yeah.
So
we have
no, not sum, mean.
Perfect.
Is it mean or sum? Okay, whatever. We can do sum for now. That's okay. For anyway, this is okay.
Yeah. Sum is better because we'll think about it because that's not really important at least.
Yeah. So this is collapsed our entire data frame to 7.
We will now try to create models for each of these categories.
Exactly. And now what we have to do, we want to map the selling price with the revenue generated. So for example, we need to map the selling price of these categories with the revenue generated. These two will be functions, right? Or actually the revenue generated is the output. But what we are interested in is the other functions. So one is the selling price we want. What else are you thinking? We are thinking of the day of the week.
Shiva, selling price could be a problem because now because we have put everything together, we can create a selling price for each category, but the fluctuation between different items will show up. But I think we'll probably
that is expected. I think that is expected. Some of that will be expected. That's okay.
Okay, fine.
Okay, I think we are out of time, so I think we should sort of.
Okay, just to ask if anybody.
Yeah, I think they are. So is anyone left? Yeah, Harish is still there.
Yeah, sir. Since I have not attended last class, I was a bit confused, but at the end I got to know that we have done some operations on the previous table which we discussed 2 weeks back.
Yeah.
And we came to a conclusion that these categories, which is like food 1, 2, 3. So in that subcategories are there. So in food 1, 001 is there. That is like a different item, right?
Yeah, that is. Yeah.
So now we completely merged those items into foods category 1.
Yeah.
Then we found this revenue of each category. Now we are going for the prediction of this foods 1 category. Like that, every category we will do.
Yeah.
Right?
Yeah. Yeah. So basically, we're trying to build like a linear regression model. So we want like the output with respect to like all these X variables. So eventually what we are interested in is revenue. What we want is all these individual X variables. So we need like the selling price, we need the number of items sold, maybe even the day of the week, anything which we think from this we can sort of, it could be relevant. I think the day of the week is indeed relevant.
Yeah. Since we merged it, is it possible to find the number of items of each category, subcategory also?
Number of items. Yeah, I think we can. I mean, we'll have to do like a mean. That's the problem. We'll have to do a mean. Because once you do a group by like this, some of the details will be hidden.
Yeah.
So with foods 1, we can say that we can say that on an average, so many items are sold, so much revenue we got. So we took a sum, but we can do a mean.
But these things will fluctuate, right? So we have some kind of special discounts and everything. When we average it, then I don't know how it will work, because when we average it, then those we are eliminating those things.
Yeah, but what we are trying to do with this categorization is that usually, like for example, foods 1 might be essential foods. So usually these essential foods will follow in a certain pattern, usually. So if we do maintain the categories, there is a possibility that we could still end up with at least capturing how the sales will fluctuate with respect to selling prices. I mean, some amount will always go. The absolutely accurate thing is to take all 3,500 things, but that is very difficult. Okay, I think we should end this session.
Yeah. Okay. I will upload this on the same GitHub thing. Yeah, so I will just stop the sharing, I guess. Stop sharing. Yeah, there's some issues like when sharing was enabled, I lost the stop sharing on this main screen, so I had to stop sharing from the screen. There is a sort of widget on top of the screen where I'm sharing.
Okay.
So yeah, there is something anyway. Okay.
Okay then. So yeah, we will meet next week.
Okay. Yeah.
Okay then. Okay. Bye bye everyone.